Okay, so now that we've introduced some units, let's talk about how we can convert between them. So, meters isn't the only way that we can measure length, to kind of stick with the examples we were using before. So, here in the United States, we might use something like feet or a foot. Because what else would you measure length with other than someone else's foot? Someone in this country, I'm sure, has feet that are exactly 1 foot in length. I'm not one of those people. Very hard to estimate with my feet. So it's someone else's foot, I guess you could say, in my case. And, if you've grown up in this country, you probably know that this can also be denoted as 12 inches. Because we love doing math in 12s here, because what number could be easier than 12? Yeah, sure, the metric system used tens, but what about people that have 12 fingers instead of 10, which I have 10, so that wasn't a demonstration of 12 fingers. But anyway, what do they do? Well, they do feet to inches very easily. So, why are there 12 inches in a foot, by the way? That's a weird thing, right? And it isn't because someone had like an extra finger on each hand and then a foot that was exactly a foot and it worked out. The reason has to do with the fact that the number 12 was cutting edge technology in medieval times when these units were invented. So you can take the number 12, you can cut it in half, you get 6. So you can cut this number in half. You can cut that in quarters. You can cut 12 into quarters, you get 3. And you can also cut it into thirds. You get 4. So a third of a foot is 4 inches. A quarter of a foot is 3 inches. Half a foot is 6 inches. And what more would you ever need to do with a number, right? What else could you do? There's a half a foot, a quarter of a foot, a third of a foot. That was it. They didn't. If you did too much math, I'm pretty sure they burned you alive back then. So that was enough to get you by. They didn't have zero yet, so it was tricky times. So anyway. 1 foot equals 12 inches. These are two different units of length that we can talk about something in. And so what this can do is allow us to set up what's called a conversion factor. This is a mathematical tool to convert between the two. And so I could say that there are 12 inches per foot, or, these are equivalent, I can say there is 1 foot for every 12 inches. And what I've done is I've just written 1 twice. 12 inches is the same as a foot. So this is a 1 overall. And you can always multiply by 1. You don't change the number. So math always comes down to adding and subtracting 0 and multiplying and dividing by 1. This is just a fancy way of writing 1 for multiplication and division. And so let's bring back our little prison escapee in their taxi. This is a taxi, because it says taxi on it, just so you know. Again, I don't know why my dad got me this. He thinks I'm 5 or something. But we can measure it out. We'll go, here. Let me put it so it's not upside down, right? By the way, best tape measure ever. These things, the Fat Max is the best. If you disagree with me, we do offer bio bonds again in the fall. And I wish you the best of luck if you take it. Alright, so, or if I'm using this video in the fall, we offer it in the winter. Alright, so it's about 4.5 inches, we'll say. And we'll talk about measurement more in a little bit. But, yeah, that's 4.5 inches. So this guy right here is 4.5 inches. What if I want to know the length of this in feet? What do I do? Well, I can use a conversion factor. And some of you just instinctively know, oh, I just divide by 12. Well, that's great. That's good instincts. If you're dealing with unfamiliar units, this is a situation where you want to pay attention to how I go about this. So what you're doing is shortcutting the process I'm going to show you. So this will always get you out of trouble. And so I want to make sure that inches cancel, so I want to use the version where I have 12 inches on the bottom. So 1 foot for every 12 inches. And that means that my inches are going to cancel because I have inches divided by inches. They cancel each other out. And so then I end up with 4.5 divided by 12, which, hold on, let me warm up my brain calculator here. I'm totally doing this in my head. I'm not pulling my phone out or anything like that, because I totally had this prepared in advance. And it is, you don't see my phone calculator there, that's my brain. 0.375 feet. That's what the calculator tells me. Okay? So, that's what we have. And so now I know what this guy is in feet. I will be hit at all the parties. I'm like, hey, you want to know what 0.375 feet looks like? Bam! There you go. Look at that. Because that's how you introduce yourself to people. That's how you make friends. Okay, so using these conversion factors and setting up so that units cancel is how this works. And you can stack multiple conversion factors in there. For example, if we think about time, do one more example of this. There's a couple different conversion factors we can bring up. 60 seconds equals 1 minute. And then 60 minutes equals 1 news show. If that's still on, I don't know. It also equals an hour. I don't know why they didn't just call that show 1 hour. It'd be a snappier title to me than 60 minutes, but what else we got? Okay, so if we have 24 of those hours, then you have a Jack Bauer. Okay. I can't help it that there's so many shows that use this stuff. That's also a day. Alright. So, 60 seconds is a minute, 60 minutes is an hour, 24 hours in a day. So you could, go like, how many seconds in a day? And we're going to have to use multiple conversion factors. There's no easy way around this. Unless you've memorized this, go you. You obviously have an exciting life. Enjoy all my party tips. They might actually help you out. Alright. So I'm just like, oh, okay, well, I'm going to start out. I'm like, I got 1 day. That's what I know. You always start with what you know. Like, I knew I had 4.5 inches for the little tuk-tuk, which is the name of those taxis, by the way, as far as I've been informed. Okay, well, we're starting with a day. That's 1 day. It's 1 day. Okay. And we're going to work our way backwards. I'm going to use my conversion factor from this equivalency. And I'm going to want days on the bottom, because that's what I have over here. And so there's going to be 24 hours per day. Now I want to go to minutes. There's 60 minutes per hour. And then I want to go to seconds. And there's 60 seconds, so I can go 60 seconds over 1 minute. And then I can check my units. Days cancel, so now I'm with hours, but hours cancel, leaving me with minutes, which cancel. So I'm going to have seconds at the end of this. And so what we have is something we can carry through on a calculator. And we get 86,400. Totally gave myself enough room to write that here. Seconds. So that's how many seconds are in a day. Now you know. Now you can count the day away by seconds. Alright. So, these conversion factors allow us to convert between units, and we can stack as many of them together as we need. You could also condense this. You could use something like, oh, well, there's 3,600 seconds in an hour, and these two steps can become one. So you can do that. If you happen to know that off the top of your head, go for it. But using the information we had up here, I did it with 3 conversion factors. But if you use this one to go from hours to seconds, that would work too. So the last thing we're going to talk about in this video, besides using these conversion factors, are compound units. So what are compound units? So everything I talked about before was a unit for a specific type of measurement, like length or time or temperature. But compound units combine units of different types of measurements. Or different properties. So you've all dealt with compound units in your life at some time or another. I guarantee it. So, for example, when you're in your car and you're driving and you want to know how fast you're going, your speedometer is going to tell you your speed with a compound unit. You're going to have miles per hour. And so this is a unit of distance and this is a unit of time. So we are mixing different properties like distance and time, or length and time. Density would be another example that does this. So it tends to be a unit of mass over a unit of volume, which are two different things. They're completely disconnected of each other. And so whenever there is a compound unit, it's like, how do we know what the value is? We have to measure it. And so in the next video we're going to talk more about measurement. But these are always going to be measured. Your speedometer is measuring your speed in your car. And we'll talk about how there's a little bit of error associated with that. If you have a Volkswagen, it tends to read about 3 miles per hour fast, so that your car seems that much faster, and you're like, I'm going 10 over, why are people passing me? And the answer is because you're going 7 over, and they're all confused why you're going 7 over. Alright, there's like 3 people that have Volkswagens in this class that totally got that joke. The rest of you are just like, huh, I learned something today. Alright, so if we have something like miles per hour and we measure it out, we can use this to convert between different unit types. That's what compound units are really good for. So, another example here. Let's say you're going 60 miles per hour, which we often abbreviate as 60 mph. And we travel at that speed for, say, 3 hours. What distance did we travel? Let's scoot that down so you can actually see what I wrote. Well, this is the type of thing that you've probably done a million times whenever you've done a road trip or whatever. And we're like, oh, okay, well, what do we know? Well, this is our conversion factor. The compound unit's always like our conversion factor. And we could change the units on the compound unit. You can make it meters per second or whatever. Mess around with it. But what we do know is we traveled for 3 hours, so I'm going to start there. That's just a good old-fashioned single unit number, and I'm going to work with it. Alright, and then I've got this 60 miles per hour, and what am I going to want on the bottom of this conversion factor, and what am I going to want on the top? Well, I'm going to want hours down here, which means I'll have 60 miles on top. Hours cancel, and so I have traveled 180 miles. So I'm keeping the examples very simple. If you're like, oh my god, this is ridiculous, why am I going through this complicated process like I can do these things in my head? That's the plan. I want to keep the examples simple so that you can see where I'm going with it, like somewhat intuitively, but then recognize that this is a powerful tool, because what if it's an object that has a density of 1.5321 grams per milliliter or something? What do you do with that? Well, you do the same thing we do here, and just watch your units. So this is make sure you write your units, because it's very common for these to get written upside down. You go 1 hour over 60 miles, you're not getting miles out at the end. And if you just go 3 times 60, you'll get the right number, but you might accidentally go 3 divided by 60. And so being able to pay attention to these units and cancel them out really helps prevent the most common error with unit conversions. Alright, so next we're going to talk about measurements, errors associated with them, and then that's going to lead us into significant figures, which will be the last topic of this section of the course. So, these are very simple examples. There's more complicated stuff to practice with, but what you do to solve these problems is exactly what I've shown here. Just carefully set up your conversion factors. Maybe you gotta stack a bunch in like you did with time. Sometimes maybe you're canceling something in a denominator, so be aware that you can put something in a numerator to cancel a denominator. So there's little tricks, but if you're working on those extra worksheets, which I highly recommend, they're optional, so you don't have to work through all of them. If you're working on it and you're like, oh, this is making sense, just skip the end. The harder problems tend to be at the end. Work on those, see how they're going. If they're making sense, then you've got it and you're ready to move on. Because this is technically review, but if it's not, that's okay too. That's why we're teaching it. So just hang in there. So next we are going to talk about measurements, which I showed a little bit of. So the tuk-tuk will come back. But yeah, that's what we'll do.